Most of us experience at some time in our lives the close-knit existence of family life. A shared home, maintained by parents for their offspring, is a basic feature. Also, relationships between the members are cooperative, rather more offish. And that might apply to a wider network of kin living nearby. Most of us wouldn't question this. But scientists have recently sought to lay the foundations in biology of a new way of looking at social behavior. Zoologist Edward Wilson of Harvard University, one of the world's leading authorities on insects, has outlined a new science based on evolutionary ideas. But it is so controversial that scientists are deeply divided as to the scientific and social implications. The criticism which has been led by a senior member of Wilson's own department has first that animal behavior is masterly. When he discusses human behavior, however, he has outlined a provocative view of human nature. But he claims it is a view that can no longer be ignored by anyone wishing to understand human social behavior.
The sociobiologist sees it as a feasible approach to develop general laws of the evolution of social behavior, which then might be applied to the study of human social behavior. So we're, in effect, taking advantage of that great blessing we have of living on a planet with so many other social species, of which man is only one.
A colony of army ants on the move. This highly regimented move by hundreds of thousands of individuals is a typically impressive achievement of the social insects. No leaders take command. A chemical trail substance laid by an advance party of workers guides the column forward in a selfless, rushing procession. Edward Wilson regards the social insects as a pinnacle of social organization, and from them he believes we can uncover universal features of social life. Yet most of us would question the plausibility of such an approach.
Insect societies are based on degrees of cooperation and altruistic behavior, which is almost beyond the imagining of most human beings. The societies are often extremely complex and sophisticated in their overall workings, but the individual behavior of the members of the societies remain relatively simple. An example is the weaver ant colony that's in the potted citrus tree in front of me. Weaver ants are dominant animals in the treetops in Africa and Asia, and their colonies have tens of thousands of individuals. If you watch just one ant individually, follow it for a while, you'll find that it's really a simple-minded creature. It doesn't have much of a behavioral repertoire. There are not very many things it does. It doesn't show much adaptability as an individual. And yet the colony as a whole is an extraordinary creation. They get about to some extent from one tree to the next by forming living chains made out of their own bodies. These ants have seen the edge of this container, and they individually begin to come down on the tips of this leaf, and linking their legs and their feet together, they will, in fact, if we give them the opportunity, reach the edge of this, and other ants in this colony will then pour over the living bridge to escape to the outside.
In their natural habitat, weaver ants use this technique to move into a neighboring tree and find a new nest site. The process of constructing a nest appears as a highly coordinated operation requiring skill and subtlety. Leaves have to be pulled together by teams of dozens, perhaps even hundreds of individual workers. What takes place appears as a wonder of group action. Yet the individual ants are little more than automata, highly organized robots who are specialized in just a small number of tasks. If we were doing something comparable, we would, however, know that we were cooperating. Ants do not. Each individual is just obeying its own genes. These two ants are linking up without in any way communicating about the job to be done. A second and even more remarkable phase of nest building occurs at about the time the leaves touch. A few workers appear, each with a half-grown ant or larva in its jaws. At the leaf edge, the larva is prodded by the worker's antenna. In response, it touches a leaf with its head, producing a thin thread of silk. The worker then moves the larva backwards and forwards from leaf to leaf, so that a zigzag of silk weaves a continuous sheet, an astonishing product of joint action between two ants. Now we can at least appreciate Professor Wilson's progression from such remarkable creatures to his attempt at producing general laws of social behavior. The cohesion of a colony can be astonishing. Army ant nests, or bivouacs, are composed of up to 700,000 interlocking individuals, a living structure. We can almost regard such a colony as a single superorganism in which the individuality of each ant has been lost. But if this is the case, then what kind of relationships could exist in such a society?
The insect society is characterized by what one could call impersonal intimacy. That is to say, of course, the members of the society are just packed together all the time. They're constantly in communication. They are intimate and totally interdependent every minute of their lives, and yet this is impersonal. There's no evidence in the vast majority of cases there's any individual recognition among the members of the society. They simply recognize members of a single caste, but they have no personal relationships with any other member.
At dawn, the bivouac breaks up. The amazing thing about this activity is that all the animals involved are sterile and cannot produce any offspring. This is a problem which interests biologists enormously. The question is, how can the genes for such selfless behavior be passed on to future generations? The answer is that the queen alone, seen here beneath some attentive workers, is replicating the genes of the colony on its behalf. Queen and workers are very closely related. This means that a proportion of each individual's genes are in each egg or larva. These workers then are not just selflessly looking after the queen and her offspring, but are actually ensuring the future of their own genes. Meanwhile, other workers who are equally close relatives can specialize in foraging for food in the surrounding habitat. Any living creature or insect that can be seized is broken up and brought back to feed the colony. It's this specialization based on a division of labor that makes the insect society so efficient in its organization. Honeybees are as capable as ants of achieving a high degree of social organization and cooperation, and for similar reasons of particularly close relatedness. But from time to time within the hive, we begin to see a little flaw of individual selfishness and conflict. At one stage in the life cycle of a colony, new queens are produced. They are related, but not closely. Conflict is inevitable, since each one will selfishly wish to pass on its own genes. Surrounded by workers, they will fight until one of them dies. Selfishness and conflict have arisen almost as an exception, however, to the social insect's rule of high degrees of cooperation.
Now, there's a remarkable paradox that has become apparent in these studies, namely that the qualities that we intuitively associate with social life, cooperation among individuals, altruism among individuals, the willingness of individuals to sacrifice themselves for the benefit of others or the group as a whole, cohesion, those qualities actually decline as we go from the simplest animals to the most complex.
On this cliff face, hundreds of kittiwakes have gathered. For the few months in which they breed, these birds return year after year to the rocky ledges which they find so convenient for nest building. In stark contrast to the social insects, there is little cooperation between the individual birds. Almost none of the important features of insect social behavior can be found here. Yet each kittiwake is, in its anatomy, brain, and individual adaptability, much more complex than any single social insect. Unlike the ant or the bee, however, the adult kittiwake has evolved to survive alone. True, it may derive some benefit from others in searching for food or in warning it against predators, but it has survived in the world by looking after itself and its own offspring. Of course, it has to mate with another individual to produce offspring, and occasionally both sexes will share in the care of the young. But unlike the social insects, there is no efficient division of labor or specialization. And because each individual is not as closely related to its neighbor, a good Samaritan among kittiwakes devoted to a neighbor's offspring would simply fail to pass on its unselfish genes, and the trait would not survive. There seems to be a real barrier to the evolution of true cooperation in higher animals, since sexual selfishness becomes an antisocial force. Each seal is, of course, an individual gene machine, so it's in the male's interests to compete aggressively to become the dominant animal on the beach and thereby to be the only one to mate with the females. There's not much the female can do about this male strategy, but she does at least know that her male offspring will benefit from having the most aggressive father. This society is, in a sense, a temporary one of individuals competing and conspiring to pass on as many genes as possible to future generations.
In mammalian society, the group is less important than the individual members in their personal relationships. There is a fair long memory of events that have occurred with individuals in the societies. Bonds are formed, jealousies and rivalries are characteristic, and the whole thing is based on personal recognition.
This dominant male gelada baboon knows each of his female companions personally. His reproductive strategy is based upon keeping his harem together for as long as he can. He watches them constantly to ensure that all the offspring of the group are his alone. But raising young baboons is a lengthy business, so it's in the interests of everyone in the group to maintain some degree of cohesion. Frequent grooming helps to do this by establishing bonds. However, this group exists side by side with other similar groups in a large herd, so there's always the possibility of sexual strife and jealousy. A dominant male will vigorously defend his position, but conflict can be reduced by a suitable signal of appeasement. In fact, a lot of communication in mammals and primates seems especially designed to overcome competition rather than fostering active cooperation as in the social insects. By regarding life in a baboon group as a strategy to rear as many of one's own offspring as possible, zoologists have begun to see why baboon social behavior takes a particular form. The question now remains, can a similar approach be applied to human social behavior?
It's essential to remember that man is a mammal, and he still has a heritage of completely mammalian physiology and anatomy, and he also has a residue of the old mammalian social traits. And most important of all, the society is a construction of individuals that are concerned with their own welfare and reproduction and that of their immediate kin.
3 children helping their father on a Scottish farm. Mum, meanwhile, is getting a meal ready. It all seems rather ordinary, but it is very human, and it is a way of behaving that is specific to humans. Is it plausible, though, to regard the human family in the same way that a biologist would examine the social organization of non-human animals? In the way that they organize their lives, could we regard either parent as maximizing their genes? Raising children, as any parent knows, requires an investment of parental time and energy. But how much investment, and to how many children? One extreme strategy adopted by many animals would be to have as many children as possible, even though it might mean cutting back on parental care and thereby losing some of the children.
The other extreme strategy is to have only a small number of offspring, but to invest a great deal in the welfare of those, raising them carefully and making sure that they have a high survival rate, and in the case of social species, that they fit nicely into the society in which they are being raised. And in order to do that successfully, you have to limit yourself very strictly in the numbers of offspring. The emphasis now goes on individual survival of the parent, of the offspring, and the way the offspring are trained. That is the strategy of the wolf, the eagle, and the human being.
But the human being doesn't stick to a single strategy. Throughout the world, we find a variation in, for example, marriage patterns. In this African village, polygamy is an accepted form of marriage. Each husband may have several wives. But does this as a strategy make sense? It's easier to see the advantage to the husband's genes, but what's in it for his wives? Sociobiologists would say that polygamy may allow women to have less children, and in societies where protein is in short supply, that allows them to devote more food to each individual child. Among the Pahari hillmen of North India, men may share a single wife. Two farmers, for example, may share the same property and the same wife. It often turns out that they're brothers. The sociobiologists would see this as an eminently sensible strategy where the facilities which one brother could supply alone are poor. Since brothers have genes in common, all the offspring of their wife will in turn pass on some of their genes. So each brother, by investing time and effort in the farm and in feeding the family, is, in the biologist's view, successfully passing on his genes. Each marriage seems to be a different strategy for adjusting to the local environment, but the fact that we have marriages at all may be rooted in our genes. A few anthropologists are now prepared to take the strong view that human mating and the way in which kin relate do, in fact, have a genetic basis. Professor DeVore.
Yes, human kinship systems are almost as if they were designed by a geneticist. Indeed, it's interesting that the natives, so to speak, have been telling anthropologists for over a century that the most important thing to them in their social organization is kinship. And indeed, many anthropologists cannot even begin work in a tribe until they've been given a kinship term and developed a set of sort of expected behaviors that go with being incorporated into the kinship system of the group.
Whenever visiting a village of the Yanomamo people of South America, anthropologist Napoleon Chagnon was incorporated into the village kinship system. As a brother-in-law of the headman, the villagers knew how to treat him. In his studies of kinship and genealogies, Chagnon found that the larger villages were made up of tightly related families. And he asked himself if this degree of close kinship and the cohesion it provided might be an important influence on the size to which villages could grow. Situated as they were in virgin jungle with ample food supplies, he felt that it was difficult to see what other limitation might apply. He disagreed with some of his fellow anthropologists that competition for resources was a consideration. Yet the evidence showed clearly that the villages had evolved by a process of growth and splitting from a single ancestral village, and furthermore, no village had grown larger than 150 or so members. Chagnon wondered if there was a biological factor at work. Why the splitting? Relationships between the individual villages were poor, to say the least, and as a defensive precaution, the adult males of each village were encouraged to be aggressive, often through seemingly violent contests. This is a formal duel, intended to resolve a village quarrel. This was a pattern of behavior that the villagers also encouraged in their young. But Chagnon has suggested that this could be the seed of destruction for a village, especially when that village was so large that its families had lost their ties of close kinship. Quarrels between families happen in any small community. But in the Yanomamo, they can escalate into a violent confrontation in which relatives take their respective sides with the aggrieved parties. The breakdown of village cohesion and social order seem to go hand in hand with the breakdown of the bonding achieved by close kinship. This quarrel had begun earlier when a male from one family had insulted a female from another. The blows appear lethal, but only the side of a blade is used or the blunt edge of an axe. Nevertheless, it's difficult to see how these families can remain together. Following such a fight, one group of relatives departed. The village was splitting. Ahead of the departing families lay the problems of establishing a new village. But their small numbers meant that they would now be in real danger of raids from other villages. The Yanomamo illustrate the importance of the larger community for defense and protection, but also that large size can lead to a selfish breakdown of village cohesion along the lines of kinship. Here then, two strategies interact.
Humans have lived in small face-to-face groups for millions of years, surely. And in these groups, you're often surrounded by very close relatives, so acts that you perform that benefit them are a direct benefit. But often they're not such close relatives. This doesn't mean, however, that as an intelligent, foresightful creature, you can't come up with mutual obligations, value systems which emphasize sharing, which is sort of preeminent human trait. It occurs in other animals, but in a certain sense, human society originally was based upon the whole notion of sharing. And you find this in hunter-gatherer societies around the world.
A Yanomamo village playing host to a neighboring village. The outcome may be a peaceful political alliance, but to achieve it, a sense of mutual trust has to be achieved through an exchange of gifts. The visitors have been fed by their hosts, but already they are voicing their demands. When a return visit is made, then of course the hosts will expect their offer of gifts to be reciprocated. The sociobiologists believe that if there is a foundation of essentially selfish behavior in humans, or at least selfishness in the interests of close kin, then an exchange of gifts like this demonstrates that people everywhere can escape from that limitation if they wish. Through the development of language, by speaking to other groups, and establishing verbal and other long-term contracts with them, Professor Wilson believes that our mammalian heritage of selfishness has been overcome. But he also proposes that a society such as the Yanomamo provide us with a basis for looking at human society in other ways that are equally useful to an evolutionist.
These are the societies that are living in the kinds of economies which existed for hundreds of thousands or millions of years, during which biological evolution was taking place. So the proposition here is that by studying in detail the way these societies are organized, we can get a much cleaner insight into the biological advantage given to certain forms of social behavior.
Wilson has specified the features that he sees as biologically advantageous: male specialization in hunting and making war, female specialization in gathering fruits and vegetables and in the prolonged care and rearing of the children. This is a highly contentious argument. In describing this division of labor as biologically advantageous, Professor Wilson is implying that it is based on genetic predispositions. In the same way, there might also be genes for altruism and cooperation within the family. Such genes would be biologically advantageous because they would confer on the bearer increased chances of survival and reproduction. Here, a Yanomamo father washes his children. Does this imply a genetic predisposition towards parental care in the human male? According to sociobiologists, the answer is yes. The potential for this behavior is in the father's genes, and an individual with such a gene is likely to be more successful in raising offspring than one without. In that way, the gene becomes more widespread in the population. This is what we mean by natural selection. The patches on these maps show how the distribution of a particular gene changes in the course of hundreds of generations in a population made up of several thousand small groups. The pattern changes because of migration, and also because in each mating the gene has only a 50% chance of survival. Even if it's a not very useful gene, perhaps it's for eye color, the pattern of its distribution goes on changing. But the essential point is that it never becomes more common. Suppose, however, a really useful mutant gene occurs in the population from time to time, say a gene for cooperation in hunting, from which each member benefits reproductively. Sometimes it'll die out, but it's possible, once relatives share it, for them to derive such a reproductive advantage that it will be replicated and passed throughout the population. This is the fundamental principle of sociobiology, that genes for particular social behaviors exist, and that they have spread by natural selection. But this argument contrasts startlingly with the views of the critics of sociobiology.
Present time, not a vestige of evidence that any of the characteristics that sociobiologists, or indeed human evolutionists in general, talk about have any genetic basis. We know nothing about why some people are more aggressive than others, some people are more entrepreneurial, indeed why some people have more musical ability than others. There is no evidence at all that such individuals differ in their genes. They may be entirely the result of their early experiences, of developmental accidents in the formation of their nervous systems, of the different societies in which they live, with no genetic differences being involved at all.
A human cell that is about to divide. Slowly, the genetic material is drawn into long threads. If individuals do differ in their genes, then these differences will exist here on the chromosomes. Each thread-like chromosome carries thousands of genes. Not one gene has been conclusively shown to influence any single feature of normal human social behavior. Yet Professor Wilson doesn't doubt the correctness of his view, even though it may be prone to a common misconception.
It's a common misconception about the inheritance of behavior, especially social behavior, that there has to be one gene, one basic unit of heredity for each behavior. This would be the extreme form of genetic determinism. That is, say, a gene somewhere down there in the chromosomes that causes aggression, another gene that causes altruistic behavior, and so on. It isn't that simple. What really occurs, or a closer statement of what occurs, would be that there are many genes affecting each one of these major categories of behavior, and that, in fact, they are not, as a rule, programming that behavior so that whenever you get a certain set of genes, you always get that behavior. What they program, really, is an array of potentials.
This idea of potentials is based on the zoologist's observations of animals in their natural habitat, and a view of animal behavior that there is a range of behaviors specific to a particular species. In this family group of North American marmots, the male on the left is playing his part as a good parent. This potential is in his genes. Yet in a neighboring colony filmed at the same time of the year, the males, many of them fathers, are not being such good parents. Instead, they are furiously interacting with each other. The sociobiological view is that this too is a potential in their genes, but is only called upon in circumstances of overpopulation. Then it seems an individual marmot is better off, or his genes are, by reducing another male's chances of success than by being a good parent. The genes provide the potential for either behavior, so giving the animal a built-in flexibility, a range of potentials. This gives the individual animal the choice of responding to its environment in the most advantageous way. But this has been criticized because it almost makes it impossible for an explanation of this kind to ever fail. What's more, the critics say these observations are deeply embedded in the all-too-common tendency to see animal behavior in human terms.
One of the problems that sociobiologists clearly have not thought about is that the very words they use to describe animal behavior are derived from human behavior and human social experience metaphorically. What does it mean to talk about aggression in an animal? They have begun to talk about aggression as if it were a phenomenon of lower animals, but in fact aggression is something we get out of human history. Aggression has an historical and political meaning.
Our ideas about aggression, about war, are indeed based upon history, possibly even personal experience. But what about the individual soldier's experience of war? Couldn't this be where the sociobiologist will find aggression in the individual in a biological sense? Or could this also lead to confusion in our attempt to understand war, which is, after all, a conflict between nations rather than individuals?
People talk about aggression in many different ways and slip back and forth between them, although they're very different things. For example, people are always trying to explain why there are wars. And they try to do that by saying, oh, well, there are wars because people are naturally aggressive. What they're doing is confusing the political phenomenon war with the individual phenomenon of my taking a poke at you if you insult me. The fact of the matter is, as any of you who's been in a war knows, you don't go to war, you don't go and fight other people because you feel aggressive toward them. You go either because of ideology or because you were drafted and you had to go, and you'd been thrown in jail if you didn't, or because social pressure has been such that you've done what you had to do, or for economic reasons and so on. Wars are economic, social, and political phenomena which really have nothing to do with the meaning of aggression in an individual sense.
Nevertheless, there is in these individual conscripts the capacity to cooperate, conform, and perhaps make a sacrifice. This has to be mobilized for the benefit of the nation at war. For the sociobiologist, our genes predispose us for this. The alternative view is that training, culture, and learning alone create the possibility. Anthropologist Marvin Harris.
See, what people fail to realize is that culture is as real as the genes. In talking about human culture and the processes by which human culture changes through time, we're talking about physical phenomena. We're not talking about some abstract, spiritualized concept. We're talking about something very concrete, a mode by which organisms transmit the behavioral adaptations which they have made on one generation across to succeeding generations. And this mode of transmission of learned behavior is as important in the universe as the beginning of life.
Because they are learned, the features of culture that are transmitted across the generations are not fixed. They can change dramatically. These New Guinea tribesmen have seen changes in their style of life that couldn't possibly occur through changes in gene frequencies that would take many generations. In the last 25 years, such tribesmen have driven their first tractor and mastered the skill of flying an aeroplane. They have acquired and practiced totally new medical skills, and from a background of isolated village life have created a parliament. If processes like this have gone on for perhaps hundreds of thousands of years, the social life of human beings must have a history in which the impact of our genes will long ago have been replaced, or at least greatly modified by culture. The sociobiologists, however, seem undeflected in their confidence in their biological approach.
Biologists are aware that although there is an enormous diversity among human groups that is culturally determined, But nevertheless, this doesn't expand infinitely. These human societies are not evolving away from one another like stars in an expanding universe. There are general, universal, or near universal qualities of human behavior which need explanation.
The problem, nevertheless, for sociobiology is to probe beneath the surface of a culture and to reveal the biology. Only a few human societies have experimented with their social lives so as to make this a possibility. The Israeli kibbutz is one and has revealed a startling feature of human social life. Here at Kfar HaHoresh, several hundred people live a collective life based mainly on farming. As on most other kibbutzim, the children are raised by the collective rather than within their own families. This group of 7-year-olds have lived together from 6 months of age in the care of children's nurses and teachers. Each peer group, that is, children of a particular age, lives in its own house where they spend most of their time together, learning, eating, taking showers, and sleeping. The feeling within one of the children's houses is of the intimacy of family life. The children, though unrelated, are like brothers and sisters, and in a very deep sense, this has an influence on them that lasts into their adult lives. In particular, it will influence their choice of a marriage partner. For, strange as it may seem, it has been known for many years that children brought up together like this are found never to intermarry, despite the fact that they will have every opportunity and every encouragement. In this particular ceremony, as in many kibbutzim marriages, a young person from the kibbutz has chosen to marry someone from outside the kibbutz altogether.
בואי בשלום עטרת בלה, גם בשמחה ובצלה, תוך אמוני ים סגולה, בואי חלה, בואי חלה. כי היום ניתנת לכם ההזדמנות לבנות בית בישראל.
The groom was born and raised on the kibbutz. The bride is from outside, a nearby town. She will now have to accept the collective ideology which is part and parcel of living on a kibbutz. But in return, her membership of the kibbutz will make her the social and economic equal of everyone else.
זהו, יד ימין, בבקשה, לעבור הטבעת. איפה הטבעת? אצלך או אצלי? שווה פרוטה? לא הקלה, הטבעת. ההקלה שווה הרבה מאוד. בבקשה, אתה תיקח את זה. אתה שמאלי או ימני? שמאלי.
A marriage of some kind or other is a universal feature of human communities, and the various rules governing who can or cannot marry whom have long been of interest to anthropologists. In particular, every human society has a set of rules that involve a taboo on incest, the avoidance of marriage between mother and son, father and daughter, and of particular interest to sociobiologists, between brother and sister. Generally, anthropologists have considered these rules as part of human culture, because the way in which they are expressed seems to vary from culture to culture. Only man, the rule-making animal, has created rules of this kind, so that here, in the institution of marriage, it is believed that we can see what distinguishes man from other animals. If you like, it distinguishes creatures of culture from creatures of nature. Now, the fact that no one brought up in a kibbutz has ever married a member of the same peer group because he or she feels they cannot, even when there is no prohibition, means that we cannot maintain so rigid a distinction between what is natural and what is cultural. It is as if the members of a kibbutz who have been brought up together are in fact brothers and sisters and have a natural inhibition to avoid incest. It is in this apparent avoidance of incest that sociobiologists see the possibility of an explanation at the level of our genes.
The sociobiological explanation notes that incest avoidance is a very widespread phenomenon throughout the animal kingdom, where it serves in large part the function, the ultimate function, of avoiding intensive inbreeding, which in turn brings together genes which in combination cause defects.
And what is fascinating is that part of this seems to be solved in the human case by the simple avoidance of even sexual attraction to a person with whom you have been living in what amounts to a family relationship.
It has been suggested, then, that the children of a peer group will later avoid marrying one another because of their family-like upbringing. Between the ages of 3 and 6, they are learning to have a special kind of relationship with one another, that of brothers and sisters with whom it is advantageous to later avoid in marriage. Sociobiologists would suggest that the capacity to learn in this way and hence restrict our choice of future mates is laid down in our genes, because it offered in the earlier evolutionary history of the human family the great advantage of avoiding genetic inbreeding. But these children in the bath together are not brother and sister. In fact, they're not even related. On the kibbutz, the genes have been fooled. Now, if these children were to be raised separately on the kibbutz, especially between the crucial ages of 3 and 6, there would be no development of this predisposition. This biological insight, in effect, presents the kibbutz with a choice rather than a limitation. These insights are merely the work of Professor Joseph Schaefer. 30 years ago, he was a tractor driver. Now he is professor of anthropology at the University of Haifa. He believes that it is very important to remember that a new biological understanding need not limit us, nor need it simply suggest that what is biological is necessarily right. And he sees this from the point of view of someone whose own community has itself achieved a dramatic transformation in his own lifetime.
If I recall where my friends in this kibbutz came from, capitalistic, individualistic, competitive Central Europe, where everybody of us has been educated to be as individualistic and as competitive as he could. And we wanted to be professionals and we wanted to be merchants. And here we ended. We are collective farmers. And even those, the religious ones among us, became agnostic. And this tremendous change has been caused by a powerful ideology. But even so a powerful ideology could only for a while change so basic a system in the human animal.
Not only is the kibbutz experiment about child rearing, but it is also about the relationship between the sexes. The founders of the kibbutzim wanted to break down the sexual division of labor in the human family. Women were to be freed of the domestic chores that tied them to the house. This would allow them to go off to work and by their work become independent of men. But what do we find in the present-day kibbutz? In the collective laundry, it is the women who do the work that they would otherwise have done at home. And generally, the same applies in the kitchen and clothing stores. The kibbutz has recently been described as a place in which men and women seem to live as if in two separate communities. This may seem a harsh view, but there is, without doubt, a division of labor within the kibbutzim on a sexual basis. Now, since the kibbutzim are communities that have so successfully achieved their other ideals of creating collective farms and sharing equally their labor and income, why should they fail in this one respect? For males don't just do the farming jobs, which are often physically hard, they also are more likely to take up managerial and political posts. Do their genes predispose them to do these things? And are there genes which influence women in some other way? Or is it the case, as many people would like to believe, that men and women are interchangeable, but for the influence of coercive customs and prejudices? The kibbutz, an experiment on a scale that no social scientist could ever have devised, may provide an answer. At the moment, there is still such a state of flux in response to both internal and external pressures that a conclusive answer would be premature. But the women have had to work alongside the men in some jobs. The rules of the kibbutz prescribe that. Yet women have felt the need to be more with their children, and they have fought and won the right to do so. Each morning, mothers may leave their work so that they can join their children in their houses for what is sardonically called the hour of love. Despite the equality of work opportunity, women have preferred to return to a family role, while men have not shown this need. As a further step, women also wish to bring to an end the completely separate sleeping arrangements of their children. It's as though they feel that the social system of the kibbutz has moved too far, or perhaps too quickly, from the basic family structure of the human species, and are taking steps to correct it. And who, at the end of the hour-long visit, can deny the potency of basic human motivations as Mum goes back to work?
The influence and the impact of even so a powerful ideology is limited to a certain extent. We could implement a tremendous revolution in different spheres of life, but in this sphere we were not so successful. And that means that man can change, can modify his own fate, but not without any limits.
But the limits experienced by the people of the kibbutz have been political and social as well as biological. And we have to ask whether sociobiologists have blurred this distinction in their desire to provide universal explanations. Consider the apple as a product of an evolutionary process. If we wish to understand why it has a waxy skin, then it is to evolutionary biology, to the theory of natural selection, that we can look for an answer. But as why the apple is also a symbol for original sin, that is a social fact, part of culture and history. Since so much of us is controlled by this cultural information, can any biological principle derived from animals that have no such information ever provide a useful human life? In fact, the necessity to distinguish social from biological truth is a warning sounded by the of sociobiology. Professor Lewontin.
When it is asserted that biological truth tells us some political truth. Over and over again when that's happened, we have seen the consequences. We have seen the way in which assertions about the biological nature of man and the causes of differences between men are the justification for a series of political and social acts, when in fact a closer examination shows that it is a misuse and a kind of pseudo-scientific application to social and political questions.
We began by considering the social achievements of ants. Here, a colony of honeypot ants is in a territorial conflict with a neighboring colony. None of these creatures can really choose to solve their conflict in any other way. Ants aren't political, nor do they create codes of behavior. But unlike ants, we are free to choose, and we are political and ethical animals as a consequence. Nevertheless, Professor Wilson reduces even these features of our humanity to a biological basis.
Ethical philosophers have a way of starting with certain premises which they take as self-evident or given, and then consider whether or not these are valid by the consequences that they have. They say, for example, there are certain inalienable individual human rights. There are certain duties which a citizen has toward his society. There are certain relationships among societies which are permissible and others which are not permissible. These are given out of the almost deep unconscious feelings of the philosopher, who is not able to divine his own physiological processes any more than the average layman considering the same problems. Now, what a biological explanation or mode of analysis promises to do is, if to the extent it's successful, is to explain the ethical philosopher, to show by evolutionary analysis why ethical philosophers, like everybody else, have certain gut feelings about what is right and what is wrong in human social relationships.
Suppose human evolution could begin all over again without any influence from existing societies. According to sociobiology, it would repeat itself almost exactly. It is a belief that our genes prescribe the ground rules of our lives and that our future lies in our knowledge of them.